Hey guys, this is a continuation of the optimization that we covered in the previous video. So right now we're going to be doing number 2, and I hope you guys are able to read the question. You can just pause the video, try to read, with understanding. Yeah, so the volume and surface area for a rectangular prism, I don't think that should be a problem. Okay, that shouldn't be a problem. Yeah, now I want us to look at this one very carefully, right? So we are given this rectangular box, right? There's the rectangular box, and we're also told that the length is actually 3 times the width, okay, and the width is x. So meaning that the length is going to be what? The length is going to be 3 times x, right? So the length of the box is simply going to be 3x, and we know that the width is x, okay? And we also know that we don't know the height actually, okay? We don't know the expression for height, but hopefully we're going to be able to find it in terms of x, okay? But the nice thing is we're actually given the volume for what we call the box. And with the volume like that, 9 cubic meters, that simply means that, okay, so they're saying V is equal to 9 square meters, all right? But we actually know the formula for finding the volume for a box, which is just length times breadth times height, okay? Is equal to 9. Why are we constructing this equation? Because we want to find the expression for the height, okay? In fact, that is the first question. Okay, determine the expression of the height of the box in terms of x. Okay, so we're just going to substitute. The length is 3x. The box is, the breadth is x, which is the width, and then times h is equal to 9. So from here, what we can do is we can just simplify. This is 3x squared times h, which is equal to 9. Divide throughout by the 3x squared. We're trying to make the h the subject of the formula, okay? So meaning that h is then going to become what? H is then going to become 9 divided by 3x squared, okay? So that just becomes 3 over x squared, So we've got the expression for the length, the breadth, and the width, and the height in terms of x now, okay? So what we need to do is we need to go on to the next question, okay? So they asking for the cost, all right? They're asking for the cost equation. So it needs to look like that. Cost is equal to 1,200 over x plus 600x squared. So, but if you check here, they told us about the bottom and the top part of the what we call of the box, okay? How much this material is going to cost per square meter. That's fine. Also, they told us about the sides. So obviously the bottom and top is this part here, and that part down there, which is the base, and then the sides, it's 1, 2, 3. We've got 4 sides, okay? So now we need to, before we construct the cost equation, we need to find the area, but we're not going to find the area of the whole thing at once. We're going to do it stepwise. What's the word I'm looking for? So we're going to find the total area for the top and the bottom, and then the total area for the sides. Then whatever area that we get for the top and bottom, we multiply that with the money that they gave us per square meter, which is 100 rand for the top and bottom. And for the sides, they gave us 50 rands over there. Okay, so whatever total area that we're going to find for all the sides, we're going to multiply it with the 50 rands. So let's do it. So now we're going to say, okay, the area for top and bottom. Area for top and bottom. So you guys know, I mean, the area of these things is just length times breadth. Okay, the length here, it's just 3x, and then the breadth here is just x. So, but there's two of them, the top and bottom, and they're exactly, you know, the same. The area is exactly the same. So meaning that this is going to be equal to 3x, which is the length, times the width, which is just x, but this must be multiplied by 2 because now we're taking into account both of them, like the top and the bottom. So this just becomes 6x squared. Okay, so now this is just the area. To find how much it's gonna cost us to actually, because remember this area that we just found here, it's represented in square meters. So they said 1 square meter is equivalent to $100. Okay, so we're just gonna take whatever area that we have and then we'll multiply with 100. Then we'll know how much it's gonna cost us for the top and the bottom. Okay, so now we'll call this one C1, cost 1. It's gonna be whatever area that we have, we'll multiply with the cost per square meter. Then this becomes 600 x squared. Now we need to find the area for the sides. Area for the 4 sides. Okay, area for the 4 sides. So what we are going to do is we're going to say, okay, I mean, we know that this side and the opposite side, they have exactly the same area, right? And this shaded area here and the area on the other side that we cannot see, they're exactly the same. All right, so for this area here, it's just going to be length times height. And then to take the other side into account, the opposite side, we're just going to multiply the area for the side by 2. Same goes for this one. Here, the area is going to be breadth times height. Then to take into account the other side, we're just going to multiply by 2. So let's do that. So this is going to be equal to length times breadth. So it's 2 times length times breadth. Remember, our length is 3x. The breadth is just x, right? So this is the area for one side, but when you multiply by 2, then that becomes the area for the 2 long faces, right? These 2 faces, this one and the other one. Okay, but this we need to also add 2 times the area of the shaded part, this part and the other one. Okay, so that's just breadth times height. So the breadth is x, the height we calculated it to be 3 over x squared. Okay, so now when we simplify, this becomes 6x squared, right, plus what, plus oh, okay, I see where the problem is. Okay, so the area of this one is actually length times the height, so we made a mistake there. So the area of this face, length times height, and the other side is length times height. So the length is correct, but the height, it's actually given as 3 over x squared. Okay, so when you simplify that, it just becomes 2 times 3 times the 3 there, that's just going to be what, 18. Okay, no, yeah, that's 18. 2 times 3 is 6, times 3 it's 18, divided by x, because this x and the x squared down there, they're gonna cancel. Okay, So, and then plus, this one is fine, it's going to be 6 over x as well. All right, so when we sum the two, this becomes 24 over x. All right, so this is just the surface area for the 4 sides. It's the area for the 4 sides in total. Now this area we need to multiply it with the cost specifically for the sides, and we're given the cost to be 50 rands per square meter. So this is our area in square meter, so we multiply it with, so we're going to say, okay, C2, which is cost number 2, is going to be the area for the 4 sides times the cost, which is 50 rand, and this is going to become 1200 over x. So we now need to add C1 and C2 to find our final answer. Okay, so the cost is then going to be equal to C1 plus C2, and C1 we calculated it to be 600 x squared, and C2 that was 1200 over x. So you can see it came out beautifully. So now we're ready to calculate the x, which is the width that they're looking for on the following question. So by the following question they say that is 2.3. okay, calculate the width of the cost. Okay, calculate the width of the box. That is the value of x. Okay, and obviously we're just optimizing the width. So to optimize the width, remember what we did on the previous video. We had to rewrite this whole thing before we start deriving. We have to rewrite this whole thing in such a way that the variable that we are trying to derive is in power form, because we wanna apply power rule. So 2 times this, it's 1200, and then minus 1200 x to the minus 2. Okay, and obviously this we need to equate to 0 if we are trying to optimize. Okay, so now this just becomes 1200 x, all right, minus 1200 over x squared is equal to 0. Multiply throughout by the x squared. 1200 x cubed minus 1200 is just going to be 0. So we then divide both sides by 1200, and we're going to have, in fact we can take the minus 1200 to the other side first. So 1200 x cubed is equal to 1200. Now we divide throughout. X cubed is just going to be equal to 1, and x, when you apply the cube root on both sides of the equation, is just going to be 1, and that is our width. Okay, hope you guys enjoyed the lesson, although this one was a bit complicated in my opinion, but I hope you guys learned a thing or two, and until next time.